Today we do the very last part of the energy and work unit, which is talking about the very basics of nuclear decay. Okay? All right. So before we talk about that stuff, we had to talk about what the very basics elements of the whole concept, which is what atoms and isotopes. How many people have heard about atoms? Of course, you take grade 9 science or 10 science, you know it. How about isotopes? So first one, an atom is the what? Is the smallest building block of what that represents an element in its what? In its neutral, neutral, what we call single state or pure state. Let's say pure state, single or pure state. If you have H2O, can you call that an element? No, that's two elements together at least, which is what? A compound. You compounded two things together. Okay? All right. In basic physics and chemistry, from what we did in grade 10, yes, not 9, 10, a simple diagram called the, what does BR diagram stand for? Come on. Well, Bohr is the B. What's the R? Bohr Rutherford. Yes, so B, was it BOHR dash Rutherford, RUTHERFORD, is used to illustrate, okay, anyone remembers what we use the BR diagram for? Distribution, this distribution of what? Electrons. Yeah, let's not write the word electrons. I like to always write electrons as small e, comma, s. Always with me, e's, e or e's are electrons. Okay? All right. So that's what we mainly use Bohr Rutherford diagram for. Has anyone heard of something called Lewis diagram? Yes. Lewis diagram are basically a variant. Yes, a variant of what? Bohr Rutherford. But what's the difference? Bohr Rutherford shows you the distribution of what? All the electrons. Lewis only shows you the what? The important ones. The what? The valence. Which are the inner or the outer ones? The outer ones, because they are the ones available for what? For currency exchange, for the chemical reaction. What are the most important numbers in what? In the periodic table surrounding each what? Each symbol for each element. Like this, for example. Okay, first, what do you call the 47? What do you call the number usually placed on the top left corner? That would be the what? That would be the, so that would be the what? The atomic number, which represents what? What does it represent? The number of, yeah. Could you still say it's the number of electrons around the atom? You could, but almost no one says the number of electrons outside. They all say the what? Number of protons inside. I think I mentioned that when I talk about the strong force. Does anyone remember why? Even though they're equal, why no one refers it to the electron? Exactly. Which ones are always easier to change the number of electrons on the outside, but it's very hard to change the what? Number of protons. So that's why they always what? Stick to the number of protons. So atomic number is the number of protons inside what? Nucleus. Okay, so that's this atomic number. What about the 1 plus or 3 minus or 2 minus? That could be the what? Some people call it the what? The valence electrons or the charge, like the reaction charge. So what does 1 plus mean? How does Ag or silver react? By gaining, by wanting to gain or wanting to lose an electron? There you go. It wants to become positive, which means it has what? It has one electron in the outer shell that's willing to what? To give away or to donate. Yes. So we can call this the what? The charge for reaction. Okay. Charge for reaction. Okay. What's the Ag? The chemical symbol. Chemical symbol. How about the silver? It's the chemical name, or we can say element name. And what about that thing? It's not atomic number, it's atomic what? Some people call it atomic mass, sometimes they call it atomic weight. See, chemists are okay with what replacing the word mass with weight. They don't really care for much for gravity. It's just how heavy an atom is. So this is the atom, oh sorry, the atomic weight. Or the what? Or the what? Or the mass number. So not the atomic number, mass number. What is the mass number? Atomic number is the number of what? Protons inside of the what? Inside of the nucleus. What about the mass number? Uh-huh. No. Electrons outside. Protons and neutrons. These are the only particles that are permitted to what? Exist inside of the nucleus, or more likely make up the nucleus. So mass number is the what? Is the number of what? Of P's and what? And N's inside nucleus as well. Okay. Isotopes. What's an isotope? An isotope is a what? Just like Ali said, it's another version or a variant. I like the word variant, like variation. It's another variation of a what? Of an element, but with one huge difference. Which number is different between an atom and its own isotope? The number of protons or the number of neutrons? What would be disastrous about having a different number of protons? It becomes a whole different what? Element. Like C6. C6. What does C6 mean? Carbon has how many protons inside? Okay, what does C12 mean? It means it's got 12 total things, which means 6 protons and 6 what? Neutrons. What about O14? Sorry, N14. N14. Nitrogen 14, which means what? It's got 7 protons and 7 neutrons. So, oh. So if you change the number of protons, you change the what? You change the number of the what? Sorry, not the number. You change the actual DNA of the what? Of the element itself. But what happens if you change the number of neutrons only? You get what? You get an isotope. So what's an isotope? Simply different versions of an element with the exact same number of what? Protons. Go ahead. Protons. But different number of neutrons. Neutron. Okay? Okay? Think about it this way. It's a person who keeps what? Gaining and losing weight. They are the same person, right? Because the DNA is the same. But what has changed? The what? The weight or the mass. And that's exactly what happens for an isotope. You could have a lighter isotope. You could have a what? A heavier isotope. And that's where radioactive what? Physics comes from. You could have an element that if it's a lighter isotope, it's what? It's stable. But the more neutrons exist in its nucleus, it becomes what? What's the opposite of stable? Unstable. Unstable means what? Radiation. That's the whole name of the game. Okay? So that's what isotopes do. They are still the same element. Go ahead. The same element. It's just that they are heavier than the most common version of the element. Does anyone know what's the most common version of carbon? The one that you are 99% made of. Carbon what? Carbon 12. Carbon 12, which means what? It's the one with 6 protons and 6 neutrons. What is the common version that is used for the radioactive decay of carbon? Carbon 14. That's why they all say I'm using carbon 14 dating. Dating, basically what dates back the actual bone or fossil or whatever. What does carbon 14 mean? Still 6 protons, but now what? 8 neutrons, which is lighter or heavier than the most common one? Slightly heavier, which means it's more radioactive for sure. I mean, it's a good thing that carbon 12 is not radioactive. Why? Because you would be radiating right now. If you were made up of C12 and C12 was unstable, that means you would be disintegrating as we speak. But you have a very small amount of what? C14 in your carbon, in your body, and that's what radiates. But most of you are C12. Okay? All right. Radioactive decay, everyone. That's what we're going to talk about for the next maybe 15, 20 minutes. There are 3 types of radioactive decay for unstable isotopes. They could assume what? What's the first one? What's A in Greek? A in alpha. Yes, alpha decay. So go ahead. Alpha. Does anyone know how we write alpha in Greek? We've written mu. We've written, what else did we write? I showed you how the T looks like the tau. Does anyone know how we write alpha? If you've taken chemistry, I talked about Rutherford experiment, you should know how to write the symbol for alpha. Alpha, A is like this. Look, alpha is like this. Look. There we go. You just go like this. Yeah, well, it's almost like an infinity sign. That's the alpha Greek letter. Okay? What goes after alpha? B, beta. Yes. B-E-T-A. Okay. How does the beta look like? Kind of an uppercase B, but curved. So everyone, uppercase B is like the, or a B like this. So this would be uppercase B. Sorry. And then it has to have a tail. So you go like this. Look, everyone, this is how I write it. Done. What's the next one? Gamma, which is usually what? The most what? Harmful one. Gamma decay. G-A-M-M-A. It's like this. Yep. Yep. No. So it's kind of like an alpha, but what turned 90 degrees up. Okay. Okay, let's talk about each one in, I can't even say in detail, in some detail. By the way, everyone, obviously you know that barely any calculations will be here. The only thing you're responsible for here are what? Kind of like fill in the blanks, true, false, multiple choice. Okay, let's talk about the first one. Everyone, pencils down. The whole thing is done for you. We just got to talk about this. So, alpha decay. First of all, what's an alpha particle? What's an alpha? By the way, alpha and beta, listen up. A huge distinction between the 3. Look, alpha and beta are particle decays. An actual particle is what? Is shot out. Gamma is not particle. Gamma is pure electromagnetic light radiation. Done. It's the only one that doesn't actually what? Emit particle. It emits just what? Energy. Pure energy, and that's it. The other ones actually shoot out what? A massive particle. So let's look at what? Let's look at alpha decay. One of the most common forms of radioactive decay is alpha decay. What's an alpha decay? When the atom shoots out a what? Come on, alpha particle. How many red dots do you see in the particle? 2. And how many white dots do you see? So it's made of 2 things and 2 things. So obviously those 2 things are gonna be what? 2 protons and 2 what? And again, the red in the Nelson textbook, red is for protons and white is for neutrons. So this atom started with what? By the way, what's Pu? Does anyone know what's Pu? Uranium is one element and plutonium. So Pu is plutonium. Is it 240 protons or 240 full things? Yes, everyone. Whenever they actually talk about the element's name dash number, that number is not just the number of protons, it's the number of what? All of them, exactly. So this one has what? 240 things inside. How many were released? Technically, how many? 4. 2 of each and 2 of each, which means what? It was made up initially of how many protons? 94. And how many neutrons? About 1 time and a half. About 1 time and a half protons are neutrons. You lost how many of the red? And you lost how many of the white? So that means what? You've gone down to what? 92 protons, which is now a whole different what? A whole different element. So this is what we call it decays down, okay? Or goes down the chain to what? Uranium. And since you lost 2 from here and 2 from here, you go down to 92 and 144. So instead of 240 full things now, you've got only how many? You've got how many in total? Come on. 236, because this one has completely gone. That's the alpha particle that Rutherford used to shoot through the what? To shoot through the what? The gold foil or the gold very super thin sheet. Okay? That he found out that most of them went through. Okay? Question for you. What is the charge of an alpha particle? It's got 2 protons and 2 neutrons. So what's the overall charge of it? Nope. Again, it's got 4 particles. 2 of them contribute no charge, but 2 contribute what? It's 2 plus or positive 2. And that's why, look, everyone, eyes on me. When he shot the particles through, so the particles are what? Positive. They went through. Imagine a beach ball, mostly air, but there's a very small positive nucleus in the middle. What does positive do to a positive? Does it gravitate towards it or does it repel? Exactly. So basically, he found out that most of the particles just went through because the size of the positive nucleus is very small. As it got closer, what happens? Does it go towards or go away? So they deflected. And any unlucky alpha particle that was what? Head on, just what? Slowed down and exactly recoiled back. But most of them were just what? That just went through big, and that's how he knew that. That's how he knew that the size of the nucleus is what? A very small amount of the size of the whole what? Of the whole atom, because 99% of the atom is dead space. That's how they were able to go through. Okay? So, by the way, everyone, the only calculations I could ask you for this material is something like this. Let's look at this. Pu started with what? 240 in total, but only 94 protons. It went 4 here down, but how many here? 2. So U, 92, 236, and 24. How do you check that your numbers make sense? Come on. How do you check that your numbers on the right side make sense? Add them up. What's 2 plus 92? 94, which was the initial number. What's 4 plus 236? So I might ask you for anything that what follows this equation. A went down by how many? A, atomic number, went down by 4. So it goes down to A minus 4 with how much here? Come on. With how much here? 4. And the Z went down by what? 2. So it goes down to Z minus 2 here. And how much here? Such that if you add minus 2 to 2, what do you get? 0. So you get the Z back. And if you add minus 4 to 4, you also get 0. And you get the A back. That's all we need to know about the what? Alpha radiation mode. That's it. Okay? Is it making sense, at least as far as the number is concerned? What comes next? Beta. Hey, everyone, beta apparently has 2 modes. So if there's a beta negative, there will be no reason to call it beta negative unless we have also a what? A beta positive. Guess what? So let's talk about beta negative. So what happens here? How many particles do I have here? 3. Apparently, 1 is a what? And 2 are? Interesting. What's the only atom with 1 proton in it? They call it hydrogen what? By the way, that hydrogen is the rarest isotope of hydrogen. The most common isotope of hydrogen, or sorry, the most common element of hydrogen is hydrogen what? 1. 1 proton and no what? No neutrons. Absolutely no neutrons. Absolutely what? No neutrons. What's the second one? What's the next one? 1 proton and 1 what? Neutron. That's called H2. What's the next one? 1 proton and how many neutrons? 2. That's called what? H3. By the way, what if someone says, shouldn't you have 3 electrons? What's your response? What's your response that someone says, that doesn't make sense. You should have 3 electrons around. Exactly. You never judge by all of them. You judge only by what? Exactly. 1 plus, 1 minus. Because everything has to what? Balance out and be equal or neutral or balanced. Yes. What happens in beta negative decay? An electron is what? Shot out. Weirdly enough, a neutron turns into a what? So instead, remember when I told you that tell me the names of the fundamental forces again. Gravitational, electromagnetic. Yeah, yes, strong and weak. What does the strong one do? Just what? What does the weak one do? Exactly. The weak one is the one that what? Changes the inside of this, or the inside of this, or the inside of this. So why would a neutron turn into a proton? By what? By changing the insides of it. So that means what? Instead of 1, 2, it becomes what? It becomes 2, 1. But now we don't have hydrogen anymore because we have how many protons? What is the element with 2 protons? It exists in the sun. It's what? It's the fusion of two protons, which is what? Which is helium. So it's what? But it's still helium what? It's helium what? 3, because it's still 2 plus 2 plus 2 plus 1. So what's the equation here? Hydrogen 3 1 goes to what? Come on. Helium 3 2. With what shot out? Electron. What's the charge of an electron? Okay. Does this balance? I don't know. Let's see. What's minus 1 plus 2? What's 0 plus 3? And that's the equation for it. Okay. What's the next one? Instead of beta negative, we have what? Ladies and gentlemen, beta positive is the positive electron. Every particle in the universe has an identical evil twin. That instead of a positive or negative charge, it has the what? It has the opposite. And the first ever antiparticle discovered was the what? Was the beta positive. And they call it what? Positron. Do you know what the word positron is? It's a makeup of two words. Positive, electron. Positive, everyone. Positive, electron. I was waiting for someone to say that. So how did they actually make up the word? They said posit. That was the very first discovered antiparticle, which indeed proved the what the actual what existence of antiparticles. Now they've discovered almost all of the antiparticles. So you're asking, what's the what? What's the antiparticles of a proton? The negative proton. Seriously, they don't have a name for it. They just call it what? A negative proton. Or the what? Or the anti what? You could have called it what? The anti. You could have called it the anti electron. But they did come up with a name for it. They called it positron. So this is the equation for what? For positive. Everyone, what's C11? Come on. Carbon 11, which means what? Still 6 protons, but how many neutrons? 5. What happens here? Interesting. What happens here? It flipped exactly. So this becomes what? 6 neutrons, and which means now it's not what? It's not carbon anymore. What has 5 protons? What's B? Does anyone know B? B is boron. Okay, so we've got hydrogen, helium, lithium. What's after lithium? What's 4? So, no, sorry. Does anyone know? What's lithium is 3. I know that for sure. What's Be? Oh, beryllium, and then what? Boron. Yes. Again, let's check the equation. Everyone, what's 1 plus 5? What's 0 plus 11? All right. So how many decay modes have we talked about so far? No, technically. 3. Alpha, beta negative, and beta positive. Another one, which is called what? Electron capture. So instead of what? Instead of shooting something out, you what? What does capture mean? Exactly. It's actually what? It's absorbed by the what? By the nucleus. And what do you get now? 28 protons become what? Less. And 28 neutrons become what? More. So what happens to the number of protons? Went down. What happened to the number of neutrons? But, by the way, I'm never going to give you this as a memorization thing. You're going to have your notes for it. So all you have to do is understand what this does, and then just what? Check the notes. Okay? What's the last one? Gamma decay. Gamma decay is the only one where nothing changes. Look, how many protons do I start with? How many neutrons? Any changes? No. But what changes? What's given out? Question. Photon is the only particle in the universe with how much mass? 0 mass, which means what? It did not lose exactly. It did not lose any mass. It lost what? Energy. So that's why the number of neutrons and protons does not change. All that happened is it went down in energy. Has anyone heard of, if you do chemistry, have you ever heard of the term ground state and excited state? In chemistry, when you have an element with no extra energy, you call it what? The ground state of the element. When you give it extra energy, it's called the what? The excited state. And again, okay, remember how they told you an electron could jump levels? That's what they call the first excited state. And the what? second, and depending on what, how many energy levels have you cleared from the what? From the very first one. We talk about that more and more in grade 12 when you do the modern physics unit. Like we talk about quantum mechanics and the Bohr model and the energy of photon and all that stuff. Okay? But for now, is there any equation on this page? Why not? What's zero? Exactly. No mass changes, only just what? Some energy loss. That's why there's no what? Mass changing equation in this one. Okay? So, oh, does the mass check out here? Come on. What's 0 plus 2? What's 0 plus 3? So no mass changes. Do you see something on top of this HE? Yeah, it's a star. Any element with a star means what? Excited state. So this went from excited state to non-excited. What's the name of the non-excited state? They call the ground state. Any element with a ground state, it means what? It's unexcited. It's at the lowest energy level permitted. Any extra energy would make it what? Would make it what? Excited state. They actually call the what? The excited state. Okay. This is a good chart, everyone, that summarizes all the properties for it. Okay? Yep. Oh, so let's read about this. Gamma decay. What does it do? Can penetrate a few centimeters, like a couple of inches, of what? Of lead. That's why it's the what? It's the strongest what? Radiation. It could go through lead. How about the betas, whether the electron or its evil twin, the positron? It could what? Can penetrate a what? A few sheets, but of what? Of thin aluminum foil. A foil just means what? A thin sheet. Alpha decay, the alpha particles can penetrate what? Skin or paper, but is, can anybody guess why is it slow moving? The alpha particle. It's the slowest moving one of the decayed particles. Let's think of something else that could affect your motion beyond energy. Thank you. How massive is the alpha particle? Quite massive. It's got how many particles in it? 4. 2 protons, and these are the these are the 2 heaviest kinds of particles in the nucleus. That's why it's what? Slow moving. It's got a lot of inertia. That's why it's hard to accelerate. Nice. Okay. Well, what's gamma radiation? Photons. Photon is the speed of what? Speed of light. Thank you. Yes, exactly. Okay, everyone. What is the... Okay, here is my equation that we're going to use for the rest of the day. Okay? Everyone listen up. How many people here have done exponential relations in grade 11 functions or grade 12? This will be exactly the same level of math that is needed from you for this one. So what's the equation going to be? Look, question for you. Listen up, what does decay mean? Does the substance grow in mass or shrink? So should you have an increasing exponential or a decreasing exponential? As time goes by, you should have a decreasing exponential. Okay, so here is the equation. Everyone, let's write the equation in math first, and then I'm going to tell you what each symbol means. The first one is, sorry. Okay, everyone. A, come on, A. The amount or the mass of the element at what time? At what time? T. So this means what? A as a function of what? A as a function of T equals A. How do we say initial in this course? I. No, hold on. Don't write I. Let's write it university style. 0. In university, they never write I. They always write what? Because they say what? This at time 0, which really means also what? Initial. What's your base? You said it, Walid. No. Half. The base in these equation is always a half. By the way, you can write half as a fraction or as a what? Or as a decimal. Let's write as a fraction. What is your exponent? Ladies and gentlemen, here is what? Not just T. T with a very important number for all radioactive elements. Nope. Hold on, hold on, hold on. T divided by, raise your hand if you heard of half-life. What's the half-life of an element? I'll give you an example. It is known that the half-life of carbon-14 in your body right now, carbon-14 has a half-life of, what does this mean? We did talk about this. Huh. After how many? So how long? After 5,730 years. What? How? Exactly. If in your body right now, if we walk outside and we find a fossil, what's a fossil? A fossil is a solidified what? Solidified remnants of what? Of an old organism. Let's say we found it, and right now we measure. There's what? 1.6 grams of what? Which, by the way, would be huge anyway. Okay. Usually you do what? Milligrams. But let's say you had 1.6 milligrams of it now. If you come back after 5,730 years, how much carbon-14 would you definitely expect to find in the same fossil if it was well preserved? No. It's called half-life. It's the time that needs to pass for half of it to what? To what? To go away, or equivalently for half of it to what? Stay. So it goes down to what? How much is half of 1.6? Is that making sense? That's what half-life is. By the way, half-life is not just a term used in physics. It's also used in finance. What do you think half-life in finance is used for? It's the time it takes for the price of anything to go down to what? Exactly. They still use the term, but it made it from what? From physics. So for example, if you have a car now that's worth $3,000, for example, used car, and the half-life is 2 years, what does that mean? You want to sell it in 2 years, you better know you will not get more than what? $1,500 for it. Make sense? Half-life is just the amount of time it needs for something to lose half its value or its mass or whatever. Okay, so go ahead. Future amount equals, what did you call this one? Instead of future amount, it's what? You can say current amount, you can say present amount. Let's just call it what? Initial amount. Initial times 1/2. What is t in any physics equation? Time, just how much time has passed. Time over, yes, over half dash life. Done. That's the equation we're going to use for the 3 problems you have. Raise your hand if you've seen something like that before in grade 11 or grade 12 function. Yes, the entire exponential relation unit was basically just to make sure that you understand what's going on here. Yeah, usually it's done after you do all the quadratics and some trig and all that stuff. Although it's technically very independent from the other stuff, some teachers start with it. Depends on the style. Okay, everyone, let's do at least one problem. Come on. All right. Aluminum what? 30. Has a half-life of how much? What does that mean? Every 3.6 seconds, it goes down what? By half. What percent of initial sample will remain after what? Okay, question for you. Did they give you how much the initial sample was? They didn't. Which means what? You have complete freedom to what? To put, to put any initial sample you want. Any number. Any number. But hold on. Here's a clever choice. They're asking you what. Hey, what's a good number to use when you do percent? 100. There you go. So for both questions, we're going to assume that the initial sample weighed how much? 100 whatever. 100 tons, 100 grams, 100 millis, 100 whatever. So I want you to write assume A0 equals what? 100 grams, let's say. Realistically, if it's a radioactive element, you never deal with big quantities. All right. So, part A. A, what's my T here? Come on. No, my time, not my half-life, my full time. The 3.6 seconds is my what? T is what? My input or my variable? 10. Well, not a variable anymore. I have a value for it. 10 equals. Okay, what's my initial value? Come on. No, initial value. What did we say? 100 times what? Come on. 1/2. What's on top? 10 divided by. Great. Keep going. What's 100? Half. Okay, can someone get me what 10 over 3.6 is? It should be 2 point something. It can't make it to 3. No way. Anyone? And give me the number in two decimals. No, 2 decimals, not 2 sig figs. 2 decimals. Is it an infinite number of sevens? Oh, so it's an infinite like it. Yeah, it rounds. Even if we do it this way, I can show you more. That's the proof that it's infinite, but it has to stop somewhere. That's what's the problem with calculators. They always have to what? Have to stop or cut. Yes. So we'll call it what? 2.78. So 2.78. Do you multiply first or exponentiate first? You have to do the exponent first because that's what BEDMAS tells you. Can someone tell me what's half to the power of 2.78? It has to be a decently small number, like maybe 0.145. Great. What's that times 100? Play with the decimal point. So what do you get? Oops. 14 point. Oh, hold on. Okay, everyone. Omar is saying say percent. Listen, I already said what? 14.5 what? Grams out of the initial what? Exactly. So what's 14.5 out of 100? 14.5%. Yep. You see, whenever you make your base 100, sorry, not base, forget what I said. Whenever you make your initial value 100, your answer is always going to be a percentage. Yes. Oh, someone told me that if you raise 0.5 to the power of 2.78 as an exponent, you should get a number very close to 0.145. Now, what's the sig fig situation for the problem? 2. Is it really 2? Technically, how many sig figs are here according to our rules? 1. But apparently they count how many? They count the 0 as a sig fig. Regardless, if I give it to you as an actual test or quiz question, I'll give you more sig figs than that. So everyone, let's keep it as what? 14.5 grams. Great. Okay. What's part B? Okay. A. Same thing. 10 goes 100. 10 divided by. Yes. Yeah, 10. Yes. Yes. Aha. Remember, my half-life is given in what? What unit? Seconds. So all the time units in the problem have to be converted to what? And by the way, let's look, everyone. If I did 10 this way, what answer would I get? You're telling me that that substance decayed to what? 14.5 grams, and then what? Stop decaying? No way. Any radioactive element always what? Decays until it reaches what? Practically 0, until it doesn't become radioactive anymore. Okay? So what was the mistake here? It's not 10. It's how much? 10 times 60, which is 600 full seconds. Thank you. 600. Come on. What's 100 divided by 3.6? Sorry, no, 600. 600, my bad. What's 600 divided by 3.6? Just give me just the division. Just the 166 point. Let's say 67. Okay. Get me 1/2 multiplied by itself 166.67 times. Thank you. It should be insanely small. How small? Go ahead. 100 times what? By the way, your calculator is definitely going to give it to you in what? Scientific notation. Huh? No. Give me 3. 10 to the what? What do you get when you multiply 10 to the negative 51 by 100, or 10 to the 2? How many powers? Just 2. So this will be what? 6.7 or 72 or 71 times 10 to the negative what? 49 in what? How small is this mass? Yeah, smaller than what? Yeah, smaller than an electron. Do you remember what was the mass of an electron? Everyone, the mass of an electron is 9.11 times 10 to the negative 31. Look how many powers are between them. What does that mean? Could you ever get smaller than an electron? No, you can't. No particle exists that's smaller, or not smaller, I mean lighter than an electron. Practically, that's not just mass. It's just what? 0. Practically, everyone, practically, no more what? No more aluminum 30 exists after how long? After 10 minutes. Okay, next question. Come on. Come on. What is this one? It wants you to estimate the what, or calculate the what? Okay. What are you given? What is this? Come on. The time it passed. What is this? Initial or final? Initial. By the way, how can you know which one is initial, which one is final? For sure. When you decay, does it get bigger or smaller? Which means what? You can never start from 81 and make your way to 100. Has to start from 100 as an A0 and goes down to what? To 81 as a future. How much time has passed? What are they asking for? What's the H value? Okay, everyone, let's set up the equation. So what's the equation? A equals A0, 0.5. Can I write 0.5? Please do. I didn't forget it. It's here. I just forgot as a what? As an input notation. Remember from function? Do you always have to say f of x or y of x? In a math course. But in my course? No, I know that y depends on what? No, in function. Y depends on x. So whether you say it or not, really not a huge deal breaker. Yes. Oh, okay. What's my top here? Come on. T over. Okay, let's fill in the numbers. What's the number for A? 81. Number for this guy. Number for this one. I didn't know what this is. Physics is done. Math takes over. Go ahead. Tell me how you do this. Okay, hold on. Is this cleaned up, or could we clean up? What is the first thing you clean up? Come on. Multiply? No multiplication. Anyone who says multiply these two, complete wrong. You never touch the base until the end. Okay, so Yasmin is saying we need H to be alone. Long way to get that. I need to do one thing first. Okay, what is the most annoying number here? Nope. 100. 100 needs to be what? Divided over. Because I want to isolate this guy by itself first. Everyone, this is always the most annoying number. What do you do with annoying numbers? Do you keep them or do you divide them out? Go ahead. So you divide by 100, and divide by 100. What happens when you divide 100 by 100? Exactly, it cancels itself out. That's what's the whole point. So equals, what's 81 divided by 100? Come on. 0.81 as a decimal, like 81%. Equals just what? 0.5, 10 over h. Now, do you remember how the only way to do this in grade 11? No, in grade 11, they will tell you Start guessing. Yeah, start guessing. Guess a power here, forget the age. Guess a power here that when you raise 0.5 to it, you get what? But no. Oh, like you start what? Proposing values and doing 0.5 to 7, 0.5 to 8, 0.5 to 9 until you hit as close as what? 81. Now I'll teach you the easy way. All right, everyone, eyes on the screen. This is how we're always gonna write our what? Our solution. Look, 10 over h equals. What did we say we're gonna use? X or log? Log. Fraction. Log of 0.81 over log of point what? How do you plug in log? You've got your cell phones or your calculators. I'll show you how I do it on mine. Look. Okay. Do you see this symbol right here? Or this button? Where is it? Log. You click the number. Mine has to put the number first. So I have to put the number first. What's my top number? Point what? 81. Look, everyone. Here's my log. It's whatever it is. How many decimals do you think we should take? Depends how accurate you want to be. I'll go with 3. So I'll go with what? 0.915. With a what? Don't forget, the negative is hugely important. So what is it going to be? Equals negative what? 0.0915. Okay? Do the same thing to this one. Clear? What was the other one? 0.5. 0.5 log. That guy. So I'm going to choose negative 0.301. Come on. Negative 0.301. Can I now, by the way, can I cross multiply now? Oh, I'm doing step by step. I'm doing step by step. Now, can I cross multiply now? Look. Hey, what's up? Me? Okay. Everyone, can I cross multiply now? I could, but could I just divide and get rid of the negatives? Come on, make your life simple.
Let me just see.
Please.
Can we cross multiply now? The answer is yes.
Hey.
Why is it yes? Someone tell me.
Go, everyone. Tell our principal why.
Why can I cross multiply?
Miss Messenger, that was an ambush, huh?
Okay, Ali, tell me. Why can I? Tell me why. I need to know. How come I can cross multiply now?
So can you tell me what's the line that should follow after this? So negative 0.0915 times what? H equals negative. If I multiply 10 by this, I just move the decimal point over, and I get this one. And what's my final answer? You see, they're good. They were just stressed out.
Okay, I got it, guys. Thank you. It's been a little bit
Okay.
of time since I've taken
Come on.
high school math, so I need to get back in the zone.
Before enjoying your deserved lunch, can someone tell me the final answer? Come on. 33 what? It will take 33 years for this element to decay from 100 to just what? It will take you 33 years to lose 19 milligrams. That's how slow it decays.
That is slow.
33 years.
Sometimes